Hello and welcome to Freedom Area High School's 4th Annual Science Conference. My name is Brian Wargo, and our theme for this year is Living in a Post-Truth Era. I just want to start off right away by showing this beautiful inscription. The question is this real? Is this a picture? Is it a painting? Is it some combination, some electronic hybrid? But that's the thing. We see something, quote, natural there, but we also have an artistic expression. And so when we look at things, we have to think, is it art or science? Many of us think it's a divergence between these two ways of knowing things, but I claim they're not. Art can be manifested in many ways. Here is a picture of the COVID-19 virus, and the artist is depicting what we think it looks like. Of course, the virus doesn't look exactly like this. However, you can see some beautiful pieces of, receptors and the proteins around this lipid, and that's kind of what our body's going to be using either to detect, or we're going to use a vaccine to hopefully plug up those receptors. But either way, in many ways, this horrific virus is beautiful in many ways, at least depicted by the artist. And art and science go together, but there's always tension. So in this particular picture, you can see we have the businessman, and then we have the scientist, and they're fighting for the art of persuasion. Should we be persuaded by the business and economic argument, or should we be persuaded by the scientific evidence? And of course, we've got a doctor in the back, and to the left, we've got Mr. Pence, which is a politician, and maybe some Secret Service back there, governors, things of that nature. We're all fighting for the art of the experience and getting people to listen to us. But there's real tension in there, and something that we need to deal with. For instance, this is about a month ago. We're talking about the coronavirus and the number of deaths and cases and so on. In the United States, unfortunately, since then has surpassed and taken the lead with deaths and cases, mainly due to our slow response. But we use this data, and there's art in this particular inscription, this graphic. But we have to be very careful about interpreting this. Can we rely on the data? If we don't have trust or confidence in that information, then it's really just art and nothing more. So when we talk about science, we need to talk about what is the objective of science. And it's really to produce explanations to help us understand the world that we live in. And these should be empirically based, gathering data and so on. It should be theoretically consistent, and it should be based on facts. And facts in the post-truth era is going to need to be explicitly defined. So on this particular picture, I have a thermometer, and facts are simply observations that are reliable measures of reality. So all of us should be able to look at this thermometer and read that it's at 0 degrees. And as long as the thermometer is calibrated appropriately, and we're at standard temperature and pressure, we know that water forms into ice as the molecules slow down, and any observer should be able to come along, look at that same exact thermometer, and also say, hey, the ice is forming probably because the temperature is 0, the molecules have slowed down. And that's the other piece that we need for an explanation. It should have a mechanism, and it should be based on naturalism. So we talk about molecules and atoms and kinetic molecular theory and so on. They're not superstitious, they're not whimsical, they're not anomalous. No, these things are going to be based in things that we already know. So one of the big ideas is scientific theory. So we only have a few of these. We've got gravitation, quantum mechanical, atomic theory, evolutionary theory. And the idea is that molecules are going to end up moving faster as we heat up the ice, and maybe we're making water, or water heating it up. Those molecules will end up colliding more and taking up more volume, hence pushing up that alcohol through the glass tube. So that's what an explanation is all about. Not personal, not whimsical. Now there's other domains that will claim that they are truth, but science is not truth. So we've got some of the ancient texts here, and they claim that if you read these, you'll understand truth. We also have some economics books, and we've got self-help, and we've got health, and most of these I would steer clear from, especially the health stuff. Most of it is not based in science. The big thing is science is not truth. It is not what the others are claiming. So, if science is not the pursuit of, if science is not truth, we should say it's the pursuit of truth. So, what is science? Here's how I'm going to put it. It is the systematic evaluation of evidence and theory filtered through the social practices of scientific critique. Critique is what we are doing with our long terms and having this gathering. Everyone's going to be able to examine everyone else's good work. So critique, that's part of the social practice, and the systematic evaluation of that, and looking at the evidence that people are portraying in their long terms, under the guise of theories and laws. And here, critique is the creative solution to new and old problems. So you're going to see long terms that have new solutions that are novel. Creative scientists find new ways of not only testing what is already known in science, but also in finding and creating new ways of explaining it. So hopefully you're going to see this statement in your mind as you look at some of these long terms. Now, explanations get modified. Let's just think of it this way. Science is the pursuit of making what we know known better. That's a good way to think of science. So we're going to have to take things that are not true, but we can get closer to truth. If they were true, they couldn't be improved. And this can require that we take our old ideas and replace them totally. And they've got to be able to withstand the scrutiny of critiquers. One example that I'd like to give is, here we have Charles Darwin, 1859, The Origin of Species comes out, and he's explaining how species change over time. And in order for this to happen, the Earth has to be a very, very old system. Unfortunately, looking at the top scientist of the day, Lord Kelvin, he said, no, the Earth isn't that old. It's, of course, not 6,000 years old or 10,000 years old, but he said about 25 million years old. And he was using a thermodynamics model. And boy, that's a pretty tough one to overcome for Darwin. In fact, gave him pause. Thankfully, Madame Curie comes along and scribbles in her notebook that this thing called radioactivity is probably the mechanism of why the Earth is staying warm. And Madame Curie allows Darwinian theory to come alive. So, do you have to be a Madame Curie or Lord Kelvin or one of these great scientists to, make a contribution? Does your IQ have to be incredibly high? Do you have to be the best student? Well, here's just from the ETS, the Educational Testing Service, and I just looked this up very quickly, and it said, what is the IQ of each major, the average IQ? And if we can look at the top part of this, it says physics and astronomy, 133, mathematical sciences, and these are going in ascending or descending order. And then you have engineering, a lot of engineering, chemistry, engineering, theory of religion, biology, and so on, right? And you keep going down and down and down. And supposedly these correlate with less high IQs. And then we have like psychology, which is, kind of a science, social science, curriculum, and then we've got elementary ed, early childhood education, social work, and so on, right? So maybe there is something to it if you buy into this idea of IQ. And when we look at the reports and studies done, we can see that like the ASVABs, which is a highly used test, and our modern tests are like these quasi IQ tests. And we thought for a long time that IQ was set when you were born. And they kind of correlate, and depending on what you're using here, looking at the SATs and various tests, pretty decent correlation. But when you look at other metrics, they're not as good for talking about IQ. That's once again if you buy into IQ. It is a metric and it is validated, but what is it really testing? And that's the trick part. But one thing that we have noticed is what's called the Flynn effect. And this Flynn effect has shown that if we look at the graph on this graph, America is red. Over the last 100 years, we have increased our IQ of our average citizen by about 30 points. And then you'll notice Asia is this yellow line right after the war, World War II. They start their industrial revolution and they are skyrocketing and they have surpassed us on the change in IQ. Africa is lagging way behind, but I imagine as we industrialized Africa, we are going to see them spike up very quickly. So, of course, as you increase wealth, you are going to have more time to read books and studies and have cognitive distributed systems like science and engineering separating and so on. But I really like this one. The average person in 2012 has the IQ that would beat 95% of all the population back in 1900. And that does correlate when we look at these metrics about lifetime earnings and earnings in any particular year. So this green line is the median salary for a median employee, 50,000, 100,000, 150,000. This is from pay scale in 2016. And you'll once again notice engineering, physics, engineering, math, engineering, chemistry, geology, and so on. And as you work down biology, there's just a ton of biologists out there, and so on. And then at the very bottom, you have education. All right. So let's think about this post-truth environment. And we think about IQ and intelligence, and we have to ask, have we peaked? And maybe we have. You've got this Stone Age creature dressed in a zoot suit, and he can use tools, and clearly he can think about the future, and yet his choices are rather odd. In this post-truth era, we have knowledge claims that are becoming, I like to say, personal, like as long as it makes sense to me, and they're whimsical, and they range from the silly, like here's the flat earth, right? I mean, let's face it, this one is silly. To those that maybe not so much, right? Maybe these aren't as silly. They still are. This idea is the daily detoxing by drinking gallons of water each day. It's nearly plausible. It almost makes sense, unless you think about it from a scientific perspective. Then it's still a little bit silly. And then, of course, in the post-truth era, some of these can range to the deadly. Here's this gentleman who is going to fly a rocket. He's not a rocket scientist, but he had some money, and he built a rocket, and he's going to launch himself up so he can see if the Earth is flat or not. We already have these solutions. They're called satellites and airplanes and things of that nature. But either way, tragically, he ended up dying. So post-truth era can be deadly. Look, we need science more than ever, and that's why we're having this conference, and we will continue to have these. But, you know, I like this picture here of the Statue of Liberty. Looks like our democracy is drowning from the rising sea level, and maybe that's a metaphor for our future. We really need scientists more than ever for our democracy, for our Earth, for our life. And yet, 81% of Americans can't name a single living scientist. And according to the occupational employment statistics, there's over 5 million in the United States, depending on how you define scientists. And there's 1,700 NFL players. And so I ask you, how many NFL players can you name? And then how many living scientists can you name? And I think most of us will say, oh, that might be a problem. Another problem is in this post-truth era that we kind of live in isolation. And here we have, just taking this picture here, someone who has their Batman shirt on. We like the idea of fiction. We like fiction more than nonfiction. They could possibly use some more exercise, but like most Americans, yet most of us will sit in front of some kind of screen and will interact with video games or something like that, which is detrimental to our brain. Just like sitting on the couch all day is physically bad, watching video games and interacting with them mentally is not very good. And yet, whenever we do have a little bit of time, we're stressed out about our video game, or we can't afford another video game, we got beat, or whatever it is, our general health, we go out and we are smoking again. We've tricked ourselves into thinking we can smoke again. And despite all of the science showing us the health risks associated with this, we still do this. We pay money to put things into our lungs that are making other people lots of money. And it is like a tragic flaw of the human condition. And this is just one of the many things that we have going wrong right now. Here's 2015 PISA data. And if you look at these over on the left column, we've got our math. Red is the United States. Purple is average. So despite us spending incredible amounts of money on education, which is still not enough, but compared to other countries, we are not showing the results. We're way below average mathematically. Reading, we're just barely above average, and science, the same thing. So we're the richest, most powerful country in the world, and yet we're barely above, or we could say we're average. But here's the real problem. According to the National Assessment of Educational Progress, you'll notice the years, let's just look at 8th graders, we can see that as the years have been going by, it seems as though we might have peaked, and now for the first time we're coming back down. This is disturbing. So why long terms, and how does this fit in? Well, long-term projects model real science. They model it authentically, how science is practiced. You can experience nearly all of the aspects of science, nearly everything, materially, actually doing physical work, theoretical work, and socially how we interact. And this might be the new norm. Now, long terms we know are very difficult to achieve these things. So ask anyone who's done a long term, are they difficult? Everyone's going to say yes. Ask, are they worth it? Everyone's going to say, oh yeah, I learned a lot. That was really hard, but whatever. The real question is, ask the world, are you happy that we're training young scientists for the future? And the overwhelming answer will be yes, thank you very much. Because the next time a pandemic hits, we want to make sure that we're not going back to this, where we end up having sick people and we call in the shaman. We'd much rather have scientists helping with that. And in this post-truth era, trying to distinguish between the two is getting more difficult. So we look forward to these students and all the students that have completed long-term projects. When it's your turn to run the world, hopefully it'll be science-based. Thank you very much, and more information on the science conference next. Thank you very much.